Thank you so much, Bob, for joining us on our podcast. Let's talk about data. I think this is the first time we are having this video call. Normally, whoever I'm interviewing or getting onto the podcast, I got a chance to talk to them. But I think for first 10 minutes, we will spend to know each other. So tell us about yourself, your background, your history, data, and anything or everything you want to share.
Well, I've been working in the IT space now for 30 some years, approaching 40 years actually. I started out doing laboratory information management systems,
Hmm.
very customized because back in those days you couldn't hook laboratory instruments to computers very easily.
Yeah.
So I have my PhD is in analytical chemistry. So that's how I got started. But then after a while, we got to the point where they made instruments with interfaces for computers. So I had to either go back into the chemistry area or stay in the data. So I stayed in the data area, designing databases and such. So over my career, I've been employees, I've been consultants, you know how it goes. And I worked for 8 of the Fortune 100 companies so far. That's quite a few. So I'm used to these large environments, complex environments, and architecting solutions for large organizations. I also have 10 patents, U.S. issued patents on data design and data architecture design and implementation and such. So that's pretty much my background. I started MaxPhase a couple of years ago because we've had some interesting developments from the patents, right? And that's where we are today. So that's why we're speaking because of our mutual interest in data.
Awesome. Awesome. It's bridges, garbage in problem, and universal data interoperability. I think this interoperability is one of the biggest challenge when we integrate. Thanks for bringing it up. And then we are saying distributed data fabric. So I think let's start with garbage in. I think it's a garbage in, garbage out concept, which is you're highlighting. Let's talk about that.
Yeah. Well, the garbage in problem is actually what we're trying to solve with the work we're doing here at MaxPhase. We have a report from Stybos Systems that only 25% of the executives in companies trust the data. So there's 75% that don't trust the data. We also see a lot of things on LinkedIn about how messy data is and how complex it is and all that.
Yeah.
And my feeling is that it shouldn't be that complex. So I was looking at data integration and ETL and all these other things that we use today and saying, is there an easier way of doing all this?
Mhm.
So, so I got to looking at what the problem really is as far as the garbage in. And it turns out that a big contributor of that is the fact that we have the source data systems as being siloed. They're disparate data sets. You can't query across the data sets, right?
Yeah.
So in reality, if I can't query across the data sets, what sense does it make to extract the data and put it into a new data set, right? Because you can't go and audit the result. You can't audit the target data set against the original data sets.
Hmm.
So I can't justify what was done, right? And I can't resolve any problems that I see because I can't see the problems. So the whole methodology to me is what we're referring to as garbage in. And then of course that affects all your downstream systems, right? So you use ETL as you talked about earlier, right? For doing data integration. You're doing your data warehouses, but even the more modern methods, data mesh, right?
Yeah.
Semantic knowledge graphs, all that are dependent on these source data sets that are disparate.
Yeah.
So that's what we wanted to talk about as far as the garbage in and how to eliminate that particular problem. So the universal data set interoperability is our solution to this.
Awesome.
So to solve the problem, we want to actually make the data sets so that they're compatible, so that you can query across them, right? So we want to enforce data integrity in our source data sets. So imagine, if you will, now you have a database, a relational database, right? You have a bunch of tables in it, a bunch of foreign key constraints, right?
Yeah.
But you turn off all the foreign key constraints and you populate the database. Well, what do you end up with? You end up with a mess.
Yes.
It's unusable, right? Well,
Yeah.
that's what I'm seeing in our data architecture. So we have all these clusters of data, and the quality of the data might be fine, but as far as going across data sets, it doesn't make any sense because we're not enforcing any kind of integrity there.
Yeah.
So the effort is, if we enforce the data integrity across these data sets, we now have the ability to go and audit, the results against the foundation, which is what we're actually building. A foundation of we call it a data fabric, or a distributed data fabric is
Yeah.
what it comes out to be. So that's what I wanted to
Okay.
discuss this morning with you.
Which is good. I can jump into it because I'm a solution architect and I can ask so many questions, right? With your
Well,
permission. So you're saying this universal dataset interoperability is your product, right?
it's the solution to the problem, because what we're doing is we're now enforcing data integrity between these source data sets.
Okay. So
So we're
how
making
you're connecting? You're connecting directly a JDBC connectors, or you have some kind of virtualization layer where you bring everything virtualized in your product and enable the primary key. How you do that?
No, it's really that it's a design issue. So we're designing the data sets just like we design within a database, right? So that we have referential integrity.
Yeah.
We're adding data integrity to the source systems, so that we're enforcing commonality across the source systems.
Okay.
So the way to do that, since we have all these source systems, we have millions of source systems, right, that are already populated with disparate data. So you can't go back and overwrite any of that.
Correct. Correct.
So we add to it. We found out that these data sets are actually incomplete. They're not anchored to each other. And that's where you run into the first problem. So we add the anchor points into each data set
In source
as
system.
we call
In source.
in the source system. Yes.
Okay.
Okay. And it's done non-invasively. So we encapsulate the existing data set
Hmm.
with other tables. They're standardized tables, though, right?
Okay.
So we encapsulate the data set, and now that becomes the data context for the data set. So we found out that the data context of the data set is how data sets interact. And this data context is that shell of master data and metadata that encapsulates each data set, right? So it's not something that we focus on today for data modeling or anything like that. But when we did our experimentation
Hmm.
research, right, we found out that the data context is the most important part for interaction between data sets. It always interacts through this outer shell. So we replaced the shell, right, with what we call our standardized shell. And now each data source looks the same from the outside, and the interactions are the same across data sets, right? So we're setting up relationships between these data sets, so you can now query across the data sets, and you building basically a data fabric.
Okay, let me go a little bit deeper into it, right? Have you heard
Okay.
about this hook? No, not hook.
Yes.
No, no, Papini Bridge, which is USS. Papini Bridge.
No, I haven't heard of it.
What about hook? You have heard about hook?
I hook. I talked to Andrew.
And report.
What's
Yeah,
his last name? Yeah, yeah.
yeah,
About that, because he was getting towards sort of what my patents were, right? So we
yeah.
were having discussions about it. But this is the concept is that these core data into these master data management, or I'm sorry, master data entities are very important as far as the interaction. So we just apply them to each data set, and they connect to each other across data sets, and that's how
Okay.
we do it. So you have, for example, we have addresses, right?
Okay.
So we have addresses in one data set, addresses in the other data set, and
Yeah.
they're in their native form.
Yeah.
So we take a standardized entity and put it there and relate it back to the original addresses. Then we take the content of the addresses, send it off to our address validator,
Okay.
right? They send back the standardized form, and we plop that into our standards, and then relate it back to the original stuff. So we're displacing the disparate data context with a standardized data context, and that's what's allowing all the interaction between systems. And like I say, we're doing it non-invasively, so we don't change any of the data that's in the original data set. We don't alter the structure. We add to it, but we don't alter it. So the systems are still the same, but it has now this encapsulation, which gives you the universal direct interoperability that
Yeah.
we're
So,
looking for.
so you should talk with Francisco Papini as well. So he has this
Okay.
USS concept
Mm-hmm.
where he has a Papini bridge in it. I think his concept is somehow similar, where he also brings all the business keys into a bridge, middle bridge, and
Mm-hmm.
then he creates a surrogate key, something like that. I won't go into
Yes.
details. And he also adds a column in source tables. He also do that.
Okay.
Because of
For a
that,
foreign key column.
yeah, foreign key back to the source tables. And when you pull it into the BI tool, you bring this bridge table and all source systems tables into one place, and there is no Cartesian. I think Cartesian is the biggest problem. I think you're
Mm-hmm.
also looking into it. Maybe once we go further into detail, maybe I can set a session with him, with you as well, and we can see
Yeah.
how similarities are there.
So people have been using bridges across data systems for a while, right? So banks tend to do it. They have a standard, which is their routing number and their account number, right? So anytime you're dealing with a bank, they want to know your routing number, which gets you to the bank, and then what your account
Oh,
number is, and then
yeah,
whether it's a
yeah.
right. So that becomes a standard that everybody uses, and
Mhm.
now that's how they interact across systems. But this isn't about passing data, right? This isn't about data exchange. This is just about making the data systems themselves compatible in place,
Yeah. So
right?
you are referring to the reference tables. So Papini Bridge do not, it's not a reference table. It's something he generates based on the business keys, and he
Hmm.
kind of a Cartesian kind of thing over there, and which allows that you can drag any column from any source table. They will not be a Cartesian. So it's a topic. I think you can research further. I can share some documentation on it. He has a
Yeah.
blog
Okay.
post as well onto it. So coming back to your this interoperability, when you say it's a solution, but you do have a product, right? It's your product, or you simply go in into the data model, you create something. It's just professional services you provide. How it goes?
Well, it is a product, right? So the product is actually a database table, a
Okay.
standardized database table, and then standardized content, right? So it's just like a database table that you would put into the database. The reason we want to have standards is because you want everyone to use the same standard so we can communicate, so you can do interoperability across data sets and across organizations and even within or across industry. So if you have a healthcare industry and you have a standard for defining patients, right?
Yeah,
So there's a way of connecting all that stuff together, and that's the solution. Now, obviously, when you do data integration, there's a bottleneck, right, with data integration method, which is when you bring everything together, there's only so many systems you can bring together, and
yeah,
then you get all the code complexity and all that other stuff. So with the interoperability, these systems remain separate. So you independently update or enrich each data system with these standards, and there is no bottleneck in this. So you can do them, as many as you want, and it's unlimited the number of databases of source data sets that can interact or be interoperable. So that's the nice part about interoperability compared to data integration.
And it's good to hear because I never heard about interoperability solution before. So it's good we are discussing, and being a data guy, being a solution architect, I'm always looking for these kind of, I
Mm-hmm.
would say workaround, this kind of intermediary solutions which can fill up small gaps. Normally, when you
Yes.
end up implementing a data warehouse in big solutions, you normally don't look into this small solution, and these sometimes become a painful area for you for data quality. If you don't have
Mm-hmm.
a proper data interoperability, you end up bringing so different kind of codes into your target downstream, and that is where you have to fix data over there. So
Yes.
as a thumb rule, fix it as early as possible, as much as towards the near to the source. So
Shift left, right?
shift
Shift
left,
left.
yeah. Yeah. So let's go a little bit further deep into it with your permission. So, for example, we have a source system in Oracle, an application in Oracle, and let's say there's an application is SAP. My first question,
Mm.
your solution can connect with multiple type of source systems, or it has to be one type of source system?
No, you could do multiple source systems,
Okay.
but what we're finding is a lot of people don't like to have operational systems and analytical systems running together on the same thing. So they make a copy, they
Yeah.
replicate it. And now, if we replicate it, we can replicate it into Snowflake and make all of the environments the same, and then you can query across the data systems
Yeah.
that way. So it's a first copy interoperability, if you wish. You could do a denormalization, which doesn't change any of the context, which is the important part for interacting across data systems. The nice thing about all this is, though, that there is no ETL necessary after you make these data sets directly interoperable. You don't have to move the data. You don't have to transform the data. In fact, you don't want to transform the data because you don't want to make them incompatible again. So
Yeah.
you just query across the data sets the way they are. And like I say, you could do your denormalization for performance and things like that if you wish in your replication. And now in our standards, we make them dimensional, right? So they have roll up, drill down, slice and dice. So now each data set becomes a data warehouse or a data mart, if you wish, with all that capability in it. Since they're interoperable, I can now plug these systems together to build a virtual data warehouse
Yeah.
on demand, right? So now I can do on demand. I can also materialize a view, right? If I want to make performance better for bring 5 data sets together and put them into and the data warehouse remains compatible with the source systems. So now I have the ability to audit, right, back and forth. Look at what I did. Here's and justify it. All things you can't do today, and that's the big problem with the garbage in. You just don't have a solid foundation on which to build and make your business information your business intelligence and your analytics, and especially AI. AI you cannot do with the current architecture of islands of data, islands of disparate data. It's just not possible.
Yeah. So if
So,
I'm understanding you correctly, you're saying first you want to pull data from source systems into one unified place. Let's
you
say,
can, yes,
yeah. No, so you
yes,
can,
yes.
or it is your demand. Two different things.
Well, you can. I mean, if they don't mind doing it against the original systems, right? We could just
Good.
encapsulate the original system where it is, and then that becomes part of the fabric,
Fair
right?
enough. Fair enough. Now, my next
Okay.
question would be, when you say you have your own standards, I would like to understand what is those standards, because I give you an example. For example, if you go towards unstructured world and you have text or unstructured text over there, you need taxonomies and ontologies per domain. Taxonomies and ontologies are different for banking, different for health, different for telco. I think same goes for interoperability. So if you are going into a, let's say, health industry, as you mentioned, health industry codes or language from one country, or maybe US is so big, from one region to another region is different, right? You are calling things differently. So that is where
Right.
you need interoperability, right? Now, when you're saying you have your own database, you definitely have a library over there. And for every domain, you must have a dedicated or relevant standards over there. Is my understanding correct?
For every domain that is part of the context,
Context.
right?
Yeah.
Right, because it's a con. So this is a very fundamental things. It's people, places, and things,
Yeah.
right? Who, what, when, right? To answer those questions. So those are part of the context. So if you have, let's say, customers, for example, well, customers isn't really part of the context. It's because the customer is a role played by a person or an organization. So the organization's the more, and the person is the more fundamental, right? And
Yeah.
that's part of your context. So that's how you make your relationships in. So, so you see, when you're talking about different industries and all, people are still the same, organizations are still the same,
True.
time is still the same, right? Products are different, so that products may need some, you know,
Interoperability.
some
Yes.
industry specific, standards, but we haven't had an issue with that yet. So,
So I think as we are talking about context and standards, can you elaborate these? Because I feel these are the two core categories or terms in your solution. Can you explain further what is context and what a standard in your solution?
okay. Data context is like I say, by definition, it's the outer shell of master data and metadata for each data set. Right? So siloed data sets have disparate data contexts, inconsistent between data sets, right?
Hmm.
And interoperable has standardized context because that's how they so that's the big difference. Now, what the context is, this gets into some theoretical,
It's
some of my
fine.
theoretical work, which has to do with the data universe, right?
Okay.
So in doing experimentation and trying to integrate data sets together, we could do a couple different, we had some data sets so we could figure out how to do it. But there's millions of data sets. So the
Yeah.
problem becomes, how do you prove that you can do it for millions of data sets? Well, you can't do that through experimentation. So we had to go to what we call deductive reasoning, which is where you have a hypothesis and a null hypothesis, right? Only one of them is true. So our model for this was to say, well, here's the whole data universe. It's the biggest friggin' data model you can imagine, right? Where everything's linked together, and you can imagine what this would look like. And then we have to have, as part of this data universe, we have to be able to do mathematics throughout the universe. We have to be able to combine information and have everything be mathematically correct. And that's where we run into some of the problems with the disparity of data. So one of the questions was, is there one data universe, right? That's the hypothesis, or are there multiple data universes? Well, you find out when you do the analysis that there's actually multiple data universes, right? Because you have data units, and you were talking sort of about that when you talked about language, but we could say currency, right? So you have different currencies to deal with,
Yeah.
different units of measure to deal with the imperial system and the metric system. But it turns out each data model we produce is also a new data universe. It's kind of interesting because the structural metadata and the data content makes it a different universe. So each data silo represents a different data universe. And
Mm.
what we're doing with the data context, with standardizing it, we're bringing all the data into a single data universe, which is what we want, right? We want everything. So now we can interact across the data sets because they're part of the same data universe. So the data context, one of the next questions was, is our data universe finite or is it infinite, right? Turns out it's finite, which means it has an outer boundary. This outer boundary is the data context we're talking about, the anchor points
Okay.
in the data universe. So now by putting the anchor points into each one of these data systems, we're actually tying these data systems together. So now they're all linked and and that's how you form this fabric. It's kind of interesting. You may have to think about it for a while.
It's
Huh?
amazing. So I think I'm trying to relate it with entities. I think the context which you are referring is kind of entities in each system, correct? Because there's a universe in a banking system. Yeah, customer is a customer.
Mm-hmm.
Salespeople are salespeople, marketing people are marketing people, products are products, right? Product type can be different, but product as an entity is a product, right? So
Yeah.
yeah, is
But
my
see, in my world, a product is really an asset,
asset.
right?
Okay.
Because when a person buys a product, it becomes their asset. When you manufacture something, it's an asset, right? So people call it product, which is a role for the asset when you're trying to sell it,
Ah,
right? So, or you're trying to buy it, right? But once you own it, it's an asset. So
no,
that's just part of,
no, this is
huh?
this is great. So I have one more question on it. We have actually we have enough time. We have around 30 odd minutes. So I can go further if you don't mind, right? So when you bring all source systems at one place, or even if source system allow you to add a column or something in there, but there will be a challenge when you do reporting. You have to do so many joins, right? And some source system, first of all, if they allow us, it will be a big achievement. Secondly, they may
Mm-hmm.
not allow you to hit big queries because it's going to impact their processing, their source performance. So, anyways, you have to bring it outside from source system, land it somewhere, and then connect with your context and standards and run the query. But when you say you don't need to transform, then I feel you can also comment on that. Then there'll be a lot of joins, right? Complex queries will be very delayed. How do you how do you tackle that performance issue?
Well, the interesting thing, like I say, once you make the systems compatible, you have that standardized context.
Yeah,
You can do the denormalization,
you can
right?
transform. Okay.
Right. And then you can also take multiple data sets and materialize a view
Yeah, yeah.
and have it denormalized, right? So if it's something you're going to do a lot of, there may be a reason to materialize a view for performance purposes or whatever. But the interesting thing is now each data set becomes a little nugget, and you can connect each data set to every other data set. So it's not like it's a web, right? It's more like Lego bricks that you can click together as you need them,
No, I
right?
got your point.
So
I got your point. I think I am absolutely with you. If we can refer to the Medallion architecture of Databricks nowadays getting famous, right? For me, it's the same thing like old time we had raw staging and transform. Now they call it, bronze, silver, and gold. So if as it is becoming very famous, let's talk about that. So what we are saying is all source system first goes into raw, which is landing, then it goes into bronze. Up to bronze, they do not change data model as of now. I'm just referring Medallion.
okay,
And I think your this interoperability tables, whatever, can sit inside that bronze and then connect with rest of the world because rest of the world in source system have the same data model just like source system. And from here, the transform layer comes. Transform layer can be anything. It can be semantic layer directly. It can be a data warehouse. It can be a data vault, anything. But you can sit inside this bronze, or if you want to go real raw, you can go and sit in the raw as well. Am I
yeah,
getting reaching at the right
but
stage?
but we don't really look at it as layers because we make a first copy, right? And that's where the data ends up. We don't move it along. We're not
Uh,
transforming data,
okay, okay, okay.
right? The only thing, because we have it compatible at this point, we've added the standards, right? We may denormalize it. We can even add history. and things like that, derive data, you
Mm-hmm.
know. And so you could do anything that you could do with the layered architecture downstream, but we don't do any of that because it's not necessary, because we're not trying to integrate the data. We're leaving it separate so we can make it interoperable and just deal with the
Okay.
querying across the data sets, which is
Okay.
something we don't do today. It's a different approach,
Yeah.
but it is a fabric, right? So these data sets combine, they're like Lego blocks, and you can combine whatever blocks you want when you need them just by writing a query, right?
Yeah. So okay. Now, when you mention your these contact instance, there are tables, right? There are database. So you mentioned it is a database table. When you say it's a database table, you have your solution sitting in your own database, or you end up creating a tables wherever it is. It can be Oracle. It can
Each
be
data,
database.
each database. So let's say we have 100 databases.
Yeah.
We add the standards to each database.
Yeah.
Very quick because they're very simple. So we add the tables to each database, and then they form connections across the databases. So that's how they link.
Or you create
So
the database which is at the customer end. It can be source system, and if you bring it into, let's say you bring it into Snowflake, so you end up
mhm,
creating your standards or your table inside the Snowflake, correct?
yes, apply them in Snowflake. Yes,
Okay, okay. It's not your proprietary product outside. It's something you bring it and you implement into your downstream or source
yeah.
system database itself, which can
So
be.
we're making the data context of each one of those 100 systems I talked about.
Mhm.
We're making it the same, so that the interactions between all those are exactly the same. There's no customization, right? Because it's when you have that customization that you run into that bottleneck that we talked about with data integration.
Mhm.
So this is all it. The reason we did it is because we didn't want to have customized interfaces between systems. Because if you're dealing with 100 systems, that's a lot of work, right?
Yeah, yeah,
Or if
yeah.
you're dealing with 1,000 systems. So the whole concept, we talked about the data universe a little bit, but the whole concept is this is a top-down approach of design. We're not starting at the bottom and say, what can we build from this? We're saying, if we could start from the top from the beginning, what would we actually build that would make all these data systems work together? So
Mhm.
that's really why you end up with a totally different approach, because it was a top-down um,
So actually,
attempt to build an architecture, right?
yeah, actually, as I've been into this data warehousing, spent decades on centralized data warehousing where we used to create enterprise warehousing, right? Which includes
Yes.
in 3NF, which includes Kimball Dimension, and suddenly this data vault come in. Although data vault is very old, but we categorize 3NF into a waterfall and data vault into agile methodology, right? Data vault or
Hmm.
focal anchor, right? Where you pull whatever entities you need for your reporting. So the biggest challenge currently right now is which your product solves is for data analysis. What happens whenever new requirement comes, a customer comes, hey, I want to create a, let's say, trading platform, and my sources are this 20 source systems. This is my
Hmm.
output, and based on this, my action, I will take these actions, and this is the value I will create. I will ask them what is the answers you want, and what are the questions you are expecting to ask the product, which is data product. Customer
Hmm.
will tell me. Now, next question I will ask from the customer, what are your source systems? Customer will be able to tell me, hey, I have these Oracles, SAP, XYZ, 10 source system. Now the challenge comes. Business analysts need to sit and find out where are the columns, what are the integrity checking, whether interoperability is there or not. Most of the business analysts doesn't even know that. So they jump
Hmm.
into the source system. Source system says no, we won't allow you to hit source system. You want data? Take my data. They give you the data. Now you end up bringing all source system data into raw or maybe up to bronze and leave analyst over there. Now it depends analyst is a domain expert or not. it depends analyst is a customer analyst or a third party analyst. It depends
Mm-hmm.
what kind of experience. So this interoperability is the one of the biggest problem statement where they spend so much of time because when they hit a query, they don't get a golden record. They don't get a unique thingy. That is where I think this interoperability, your product can come in and solve this problem.
Yes. Yeah, I think so too. But we didn't talk about the data fabric now so much because there's a lot you can do once you make these data sets interoperable, that they work together, right?
Yeah.
So instead of having islands of information, we have a fabric of information. So I can take information from that fabric and put it into a golden records area,
Yeah.
right? I can modularize the golden record area so that it's shared into the fabric. So
Yeah.
now everybody has the ability to connect to the golden records, right from whatever system they want. So
Mhm.
I'm sharing this information now across systems. So one of the things I do in my demonstration, I take standard industry codes, right? So
Mhm.
standard industry codes are related to the organizations. So
Yeah.
instead of putting, 50 data silos where I'd have to put standard industry codes into each one of them and make sense of it, right? Instead of that, I do it in our golden records area. I tie the standard industry codes to the organization's um, data compatibility standard, which is actually inherited into all 50 of the systems. So I only do it here. So it's a much more object oriented approach
Mm-hmm.
to building data because I'm using really usability instead of copying it all over the place. So it cuts down on the complexity of the overall architecture too, right? Because we're simplifying things, and each data system enhances every other data system.
Yeah.
Right? Instead of working apart, instead of being siloed, where you have to duplicate stuff, we don't
Mhm.
have that anymore. So now we can make a nice smooth fabric, and that's an ideal layer for AI, right? Because now
Yeah.
AI can go across the whole thing. So when I look at the current architecture, we have these islands of source systems that don't relate,
Yeah.
and you can't do anything across them. You can't do auditing across them. You can't do justification, resolution, nothing. And instead, have a fabric there where it's an open book for the enterprise. All your data is accessible, right?
Yeah. So
All
Fabric.
your data is findable.
Yeah.
You have these reusable standards and then the reusable golden records because that's all inherited into your fabric,
Mm-hmm.
and then you have the interoperability. So this is what they call the FAIR. You've heard of FAIR principles in
Yeah.
data, right? Findable, what is it?
Mhm.
Interoperable,
Yeah. Yeah.
uh, accessible, and reusable.
Yeah.
I didn't do it in the right order, but
So Fabric, when you're saying when your this standards and context, these tables come into picture, the whole thingy you are calling it as a fabric, correct?
well, yeah, because they act like a fabric, right? Everything's connected now.
Because you, just for my audience, we use two terms now. We are using universal data interoperability and we are using distributed data fabric. We are using two terms.
Right.
Is it same
The
or how it is different?
the universal data set interoperability is the data sets themselves, the modular, we call modular plug and play data sets,
Okay.
right? They're analytics ready, AI ready. So each data set is its own little modular, and that's the component to the fabric.
Okay. Okay.
So the fabric is the total, right? And these are
Okay.
the components.
Okay. Awesome.
So
Awesome. So
and the fabric, you don't have to do anything to make it a fabric. Once you make the data sets interoperable, they become part of the fabric.
yeah. Yeah.
So
Any
that's kind of the neat thing of all this.
yes, because anything can connect anywhere. It's a fabric, right? And that's what you
Yep.
are referring. Okay, as we
Yes.
have a time check of 10 odd minutes, 10 to 14 minutes, the tables which you create with these standard and context and this interoperability, right? Do you
Hmm.
bring data from from your end as well, or you extract everything from source systems? How this universal data set which you have, product one product is called 001, let's say in one system,
Right.
and another place it is called 002. Your interoperability need to make sure there is one code which is referred, which is a golden record. This one
Yes.
record comes from where? Who decide that?
Okay. So we're enforcing referential integrity or data integrity across data sets, right? We didn't really discuss that. The way we do that is by providing a single source of data for the standards, right? So there's three different ways that we've done it so far. So you have calendar, for example, where we know all the, all the the dates and such. It's right. So that's a simple one. We just do that from the script, right? So we have a script that's a SQL script. We implement the data set into each one of or we implement the standard into each one of the data sets. The next one we have, well, let's talk about the other one that's a more global standard. We talked about addresses, right? So we use our address validator. So they all use the same database out there. So we send out our native address out to the address validator. They standardize it, send it back. We pop that in.
It goes via API and come back. Okay.
Yeah, and then we populate that into our standardized structure, and then just relate it back to the original data record, right? So that's simple enough. We've done the same thing with Dun and Bradstreet, by the way, for organization. So we go and get the Dun and Bradstreet, and then we get the hierarchy, the Dun's hierarchy. I don't know if you're familiar with the Dun's data, but they give you like the global site, the headquarters for the country, parent site, and then the local site. So they do it by sites, right? So that's our organization. So we send them an address and the name of the company, and they send back the matches, and then the hierarchy. So now you can do your roll-ups and such.
Okay.
So that's nice added information that we've found that companies don't have. They don't understand the relationship between organizations. So now they have that as well. So those are external sources, third-party sources, and we're hoping to see more and more of that because we want to have these globalized standards, right? So that when you standardize your data set, it's more of a global data governance, right? Because the scope of the interoperability depends on the scope of the governance of the standard, right? Yeah. And then of course you have the internal standards, which is like chart of accounts, right, for finance. Each company has their own chart of accounts that they set up. So you would have to have a registry for your chart of accounts, and then, yeah. So now product was the example you gave. Yes, you would have to have a product registry that you would set up. You would have to have the matching information in there so that it would say, oh, well, this product from this thing, the 001, is actually, product A in our standard. And then, so yeah, there is work to do, but it's a governance work, it's stewardship type of thing.
Let me add, it's kind of a replacement of a MDM system as well, if I'm not wrong. You don't need MDM.
Well, no, you don't need MDM anymore. MDM was, they had the right idea when they're working with the context data, but the concept is they never build a standard from it. They always wanted to do things downstream. So you could never fix the upstream systems, right? Because people didn't want you to overwrite their master data in their source system, their native system. So they do everything downstream. But now what we say is, well, let's just take the standard and apply the standard as an add-on to the system, right? Instead of changing the system. So we don't want to change any of the data. We just want to add to it and give you a standardized context. So that's how that'll work. So the MDM was a decent approach, but it wasn't implemented the way that it could have, as best as it could be.
It's very expensive, If you go for
very expensive, but they're also doing things, that they're doing more things than what they need to. This is the point.
Yeah. Master, we are talking about, by the way, we are talking about master data management. So actually, with this discussion, I come to a second use case for your product. So first we discussed that I feel your solution can fit into bronze or as well as raw data where we can have this fabric created. I think you can also work in the direction of ETLT as well. That goes back to the source system. That is what you're also referring. If source system agrees to add on in their source system, I think it's a
Mm-hmm.
win-win situation. Reason being, yes, you are pulling it for certain downstream, but who knows? They are also serving to some their external parties directly from
Mm-hmm.
themselves. If they are directly sending, exposing themselves to a third party, which can be auditor, which can be a dash service as well, I think your
Right.
record, which goes back as a golden record, will also serve them in a good way that they will be able to send that record outside. I think that can be a use case as well.
Right. But we've gotten away from the concept of sending data, right?
Okay.
Because we had one company that was interested in spare parts,
Mhm.
right? So they have a process going. One of their big machines has a problem. Something broke. They need a spare part. They
Mhm.
don't have it in stock, right? So the concept was we could have manufacturers put up um, their specifications for their different parts as a compatible structure, right? And the suppliers could put up compatible structures for their pricing for those spare parts in their inventory and such. And you can have your ERP systems back in
Mhm.
your say, well, okay, this is the spare part I need. Here's the specifications I need. Go find, AI, go find me a manufacturer that manufactures a part that meets these specifications. And when you find that part number, go to the suppliers. Our suppliers get me the best price and with the quickest delivery time. Right? So that sort of thing. So now it's not passing information, it's just querying across these
Yep.
data sets
Yep.
because they're now interoperable, right? But now you have three organizations or many organizations, but three different roles working together, you know, just by having this information available that they publish as public because they want to have their customers be able to find these parts quickly.
You raised a very good point here. Rather than finding a product with the name, you find it with the attributes. And whatever you
Yeah,
want to find, based on the attributes, you should find rather than a code or a name. Right? You need
yeah,
maybe a laptop with a spec of two CPUs, a RAM, a storage. You send that specification down there on the API of source system on third parties. You pick up everything, you get their code, and you have your own code as well. So your code and their code, then you generate a standard or contact standard, I guess,
yeah,
and
yeah,
that becomes
something like that.
yeah something like that. Okay.
But you just do it by querying because the manufacturer makes the specific. This was spare parts specifically, so the part name doesn't really matter. It's is it stainless steel? Is it brass? Is it that kind of thing? So it's like, well, we need brass. We need right.
Yeah. Spare parts
So
is a
that's
great
how they do.
example because a lot of companies make products, especially spare parts. There are small companies, there are SMEs, there are big companies. Everybody
It.
have their
Hmm.
own code, their own name, their own brand, right? You should go and
Right.
I think your product is I think also covering OLTP applications as well as we just discussed this application, this example
Hmm.
that rather than only focusing on OLAP, which is warehousing, that can
Right.
be one use case because when you do data lineage, if 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 interoperability is not there in bronze or landing, then sometime finding a data lineage back to the source system is become a painful process. But if
Yes.
your solution sits right up there, it's quite easy to find out, hey, this golden record have these two different codes. One code is coming from this source system, second code is coming from this source system, but golden record is going into a warehouse. It's very easy to find out. In OLAP world, as well as we just discovered, it is also very useful in OLTV. I think it's a great discussion, Bob, and I good we had this discussion because this kind of solution I'm hearing for the first time.
Hmm.
Reason being, we all talk about master data management, which are very, very expensive. Millions of millions people say pay to implement MDM solutions. And we all know that 90% of those never goes to production because it
Right. And they only want to impact the downstream
downstream,
systems, and
yes,
really it's the upstream that's just as
that need to,
important.
yeah.
So, in closing up, the most important thing of all this, the big headline is, the garbage in and the current data architecture that we have is a problem as far as data warehousing and MDM that we talked about, data mesh, knowledge graph, because of these siloed data sets that you start with. You can't verify that what you've done is correct. You can't audit the results against the sources. You can't justify what you've done. You can't resolve any of it. So that's the big problem. And we solve that with our universal data set interoperability and our distributed data fabric.
Okay, with considering this 5 minutes left, I will ask just last few questions. Quick one.
Okay.
Your product have licensing or it's only professional services you come, implement and go?
Well, we provide services through consulting companies, right? So we don't have our own consultants that do this. It's a licensing because it's IP, right?
Okay,
It's
license. Okay.
patented information, so we do licensing and give them the ability. They can implement it if they want. They can use consultants to implement it.
Mhm.
We provide standards in most cases. Some of them have, they want to, it's a new standard. They need it for their stuff. They can do it themselves.
Okay. Okay. My next,
Although we should help with the design because we have the
no,
experience, obviously.
which is fair. Now I'm wearing a my customer hat and I'm asking like how I can implement you in my organization. So first thing you mentioned is an IP, is a product, is a license. So this license is a user-based license, is a transaction-based license, or is a CPU-based? Which kind of license model you have?
No, 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 no. It's for the enterprise basically. So it's an enterprise license. They can use the standards
Oh, you
that we
you have, you
develop.
have
Or
flat. You have flat license for anyone.
yeah, yeah, yeah.
Okay.
Because our vision is that everyone's going to need this. So
Yeah.
it's a volume thing. So it's not expensive to get, right?
Okay.
That's the whole concept.
Okay. Now a question from C level that how much time it takes to implement your solution?
Well, the interesting thing is we talked about the different kinds of standards. So calendar I can implement in a matter of 10 minutes on each data set,
Yeah,
right?
yeah, yeah.
Other things where we have to do the address validation, for example,
Mhm.
that's an overnight thing, right? So we have to collect the information from the set, send it out to our address validator. It'll get back to you overnight, and then you populate the standard and you make the link back to the thing. So it's a couple days work, and then obviously you have to have someone go through it and verify it and
I
make
was
sure
about
it
to ask
makes
that.
sense.
I was
Yeah.
about to ask that. You have
But
calendar.
you can use AI for that, by the way.
That was going to be my last question because we have calendar very standard. It can be offline as well because you get the libraries. You have external parties, which you just mentioned, example. The
Hmm.
third thing is your internal thing. Yeah, that like product code internal, you have internal multiple
Right.
pauses where different kind of KYC, whatever is coming. Now someone has to review it. So that reviewing
Yes.
party, do you have an agentic AI agents or you still do it old way?
Well, what we've done in the past with the Dun and Bradstreet was the one that was the most difficult to match because we had clients. This was for institutional clients. We had clients that were not in the D&B database. So we had people work, I think we had 3 people working to verify address information, to verify the company name, to deal with Dun and Bradstreet, to get it into their database so they would assign a Dunn's number, get that. I mean, that took the longest of but it was still relatively quick because you get the Dun and Bradstreet number, you get the hierarchy, you populate it in, and we had I think we had an 80-some% hit rate on it first try until we got done with the stewardship. And so we got up to like 97%, something like that. The ones we had difficulty with was like Eastern Airlines. Well, Eastern Airlines went out of business in 1980, so Dun and Bradstreet didn't care about them, but we still had retirees, right, on the retiree plan, so we had to keep the plan. So we had to link those together, companies that are no longer in business. But that was all part of the hierarchy then, so we could group them together. So
awesome. Awesome. Again, Bob, thank you so much for your time. Thank you, Bob. Thank you for your time. And it was a pleasure talking to you. I learned something new. I learned something that there are tools in the market, solution in the market, which is right in parallel for MDM, which is Master Data Management. And I love this session. And as we just discussed, let's plan a demo on your product or solution and share it with the audience. Any last things from your end?
Well, just thank you for inviting me. I enjoyed the discussion, and I did want to point out the headline about all this is what we're doing today is a real problem as far as justifying the thing and trying to get the right results, and it explains some of the mess that we have as far as data, and we're trying to get around all that by.
Absolutely. As I mentioned, data analyst, this is one of the biggest problem for data analysts. When a new
Yes.
requirement comes, to convert that new requirement to use cases, data analysts or data, what they call business analysts, go into a source system and find out, that transformation logics. That is their stuff.
Yes.
Your
Yeah.
product can really help them. Thank you again, Bob.
Yeah. You're welcome, and thank you.
Have a nice
Have a
day.
good day. Yep.
Bye-bye.